Okay, good morning, everybody. It is December 3rd, 12:03. So, a couple of things. One, if you have not taken the test yet, Chapter 5, absolutely have to get it into me by this Friday. If you don't, it's going to turn into a 0, and it's going to be terrible for your grade. Also, if you want to retake, please let me know, and I can do a private Zoom or just a Zoom. Wednesdays, I've been trying to do Zooms for retakes, but if you want to be a part of that, please let me know, okay? So, let's talk about today's lesson. So, there's two things we want to talk about today. One is strict variation and inverse variation. So, what we're starting to hit in this particular chapter is really fractions, or we'll call them rational functions. And we'll start off with a thing called direct variation. Oh, and inverse variation. Sorry, the one I really want to talk about is inverse variation. Inverse variations, okay? So, to take a look at this, sorry about that, getting a little ahead of myself. Direct variation is this. As one thing gets bigger, the other does too. The equation is just simply y equals mx plus 0. Or, the book likes to use this k instead. Y equals kx plus 0. But don't let k bother you, because k is really like the slope. K is really like the slope, okay? And we know how to graph those. Big key, though, that if you notice, if you haven't, or I'm going to emphasize to you, is the plus 0, okay? So direct variation always goes through the origin, always. So as an example, let's say I've got a y equals 2/3 x. If I graph that, that is definitely going to be a direct variation, right? So you know how to graph that, right? Start at 0, right? Start at 0. You're going to go up 2 over 3, and it looks like this. So as one value gets bigger, the other gets bigger. Directly related, right? Inverse variation is different. So one gets big, the other gets small. Okay, as an example, I have this equation, xy equals 12. So xy equals 12. What times what equals 12? There are lots of things. For instance, 3 times 4. Well, that'd be a point at 3, 4, right? 2 times 6, right? 1, 2, 3, 4, 5, 6. Oops. Well, we could even go 112, I guess. 112. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be way up there. Hey, wait, we can reverse these. We can go 4, 3. I can, because 4 times 3. 4 times 3 makes 12, right? XY. 1, 2, 3, 4. 1, 2, 3. I can reverse these. 6 times 2. 6 times 2 makes 12. 1, 2, 3, 4, 5, 6. 1, 2. And of course, then there's also a 1 or 12, 1. My bad. 12, 1. Sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. So what happens is this. As one value gets bigger, the other value gets smaller, the graph looks like this. Now, one thing it can never be is 0. So we're going to put a horizontal asymptote here, because it'll never equal 0. And the x value can never be 0, because if you had a 0, think about it. 0 times what equals 12? Nothing. Something times 0 equals 12? Nothing. Impossible. So we have a horizontal and a vertical asymptote. Now, somebody out there might say, hey, Mr. Davies, what about the negatives? Well, what are you talking about negatives? Well, how about a negative 3 times a negative 4? Yeah, that could probably work. Because we know a negative times a negative makes a positive, so we could have a negative 3 and a negative 4. And all of these could be negatives, right? You could have a negative 2, negative 6, yeah. Okay, and you could have also a negative 1, negative 12, yeah, that's what way down here, this kind of thing. And then you could have a, how about a negative 4, negative 3, sure, yeah, right, yeah, that goes like that. Oh, and how about a negative 6, negative 2, yeah, because a negative times a negative makes a positive, which still makes a 12, right? So I have those too, so I'm going to 1, 2, 3, 4, 5, 6, 1, 2, and then it keeps going, and so it looks like this. That is the graph of an inverse variation. And these are the kind of graphs that we're going to be talking about mostly in this chapter. Okay, so let's go back to what I want to talk about. So in our notes today, I want to talk about inverse variations mostly. So if you have some x times y equals some number, we're going to call it k. And k is called the constant of variation, okay? So we're going to find k is called the constant of variation. Okay, so example 1. X times y equals negative 12. Yes, that is true. That's going to be an inverse variation. X times y equals some number. Yes, that's definitely going to be an inverse variation. X plus y equals 0. I don't know. Let's see if I can solve for y. Go minus x. Right? Just solve for x. Y equals a negative x plus 0. Well, that sure looks like a direct variation. Take a look at it. I have a slope of 1 plus 0, so that's a direct variation. 5 over x. Let's see. If I multiply up by x, let's see if I solve this. Multiply both sides by x. I'd have a 5 equals, well, an xy. That looks like it's the same as a inverse variation, right? That's an inverse variation. What times what makes 5? The problem with 4 is if you try and solve, you get an x minus 4 equals 2y. And if you divide by 2, you'd have y equals a 1/2 x minus 2. Now, if it's going to be a direct variation, it has to go through the origin. Can't have a negative 2 here. So this is neither. To be a direct variation, it has to go through the origin. Let's see. Example 5. Let's see. If I multiply by 4, bring up the 4, multiply both sides by 4, I have y equals 12 times 4x, or y equals a 48x plus 0. I can put a plus 0, and that sure seems like that's going to be a direct variation because it goes through 0. It has a slope of 48. Direct variation. Okay, hopefully this is not too bad. I'm trying to go through this quickly because, you know, it's also in your journal. Okay, then example 6. Okay, now how do you know which one it is? One way you can do is you can graph it and take a look at it. And the other is to see if they multiply. So on example 6, let's see if I look at this. It's going to go up by 2, up by 2, up by 2, up by 2, up by 12, then up by 20, up by, ooh, that is neither. That doesn't, I think if I even graphed it, it looks exponential to me. It does. It's going to look something like this. You can graph it, but that looks exponential. Exponential. If you want to graph it, check it out, but it definitely curves up like that. It's not going to be inverse. Now, how about 7? Well, one thing I noticed is 1 times 5 is 5. 5 times 1. 8 times 6.25. I think if I did that on my calculator, let's check that out. I know that's 5. That's 5. What's 8 times, oops, 8 times 0.625. Oh, I get a 5. Good. 20 times 0.25. I get a 5. 50 times 0.1. I get a 5. So it looks like x times y is always equal to 5, and that's going to tell me that it's got to be what we call inverse variation. I mean, really look at this. As x gets bigger and bigger and bigger and bigger, y gets smaller and smaller and smaller. So they're inversely proportionate, is what we'll say. Example 8. Let's take a look at it. X varies inversely with y. Okay, so we know x times y equals some number k, right? Let's go back. Varies inversely. Here's my equation, right? So I'm going to write that down. Okay. if x is 2 and y is negative 3. Okay, so then let's plug that in. I'll put a 2 here, and I'll put a 3 here. And then I can find the value of k. So in this case, obviously k is equal to negative 6. Okay, so let me rewrite my equation. Rewrite this equation as x, y equals negative 6. Okay, I know that from what they gave me. Okay, now make an inverse equation. We did that. Boom. There's my inverse equation. Now, find the constant variation. I did that. Negative 6. I did that. The constant variation is negative 6. I just did that. K equals negative 6. And now, let's use our equation. So find y when x is 12. So I'm going to use my equation. I'm going to put 12 right in there for x, right? So I'll go, all right, instead of writing x, let's write 12 times y equals negative 6. Divide by 12, and y is equal to negative 1/2. Okay, that's all I have for today. Again, if you need to get caught up, please get caught up. I'll talk to everybody in the morning.